Namaste dosto. Imagine you are riding your bicycle uphill. Some slopes feel steep, others are gentle. But how do we measure just how steep that slope is? Today, we begin an exciting journey into the world of straight lines by exploring their slope. Think of slope as the steepness or inclination of a line compared to the horizontal ground beneath it. Now, here's a neat way to picture this. Suppose a line makes an angle theta. That's the Greek letter theta, with the positive x-axis. We can define the slope, which we'll call m, as the tangent of that angle theta. So simply put, m equals tan theta. Yes, m equals tan theta. If you remember from trigonometry, tangent measures the ratio of the side opposite the angle to the adjacent side in a right triangle. An important idea is that slopes increase from left to right on the graph. So if the line rises as you move right, the slope is positive. If it falls, the slope is negative, like when your bike is going downhill. But what about vertical lines? For those, the angle theta is 90 degrees. And since tan 90 degrees is not defined, we say the slope is undefined. Moving forward, how do we actually calculate the slope if all we have are 2 points on a line? Let's say you have points A at coordinates x1, y1 and B at x2, y2. The slope m of the line passing through these points is given by a very handy formula. M equals open bracket y2 minus y1 close bracket divided by open bracket x2 minus x1 close bracket. Let me say that slowly again. M equals the difference in y coordinates y2 minus y1 divided by the difference in x coordinates x2 minus x1. Why does this work? Think of the 2 points forming a right triangle on the coordinate plane. The rise going up or down is y2 minus y1 and the run moving left to right is x2 minus x1. Slope is simply rise over run. But watch out. What if x1 equals x2? Then we are dividing by 0 and our slope is undefined. This corresponds to a vertical line, straight up and down, just like we discussed before. Arey wah! Now let's talk about two special but very important cases, horizontal and vertical lines. A horizontal line runs parallel to the x-axis. This means there is no rise. The y values don't change. So the slope m equals 0. Why 0? Because the angle theta here is 0 degrees and tan 0 degrees is 0. Simple as that. On the other hand, a vertical line stands straight up and down, perpendicular to the x-axis. The angle theta is 90 degrees and as before, tan 90 degrees is not defined. Therefore, the slope of a vertical line is undefined. Mathematically, if y1 equals y2, slope m is 0, that's horizontal. But if x1 equals x2, the slope is undefined, vertical. Remember? Recognizing these slopes helps you quickly understand the orientation of lines from their equations or graphs. For example, if you see an equation like y equals 5, it's a horizontal line with slope 0. If you see x equals 3, that's vertical with undefined slope. Let's spice things up by comparing positive and negative slopes. If a line rises from left to right, it means the slope is positive. On the other hand, if it falls from left to right, the slope is negative. Here's a quick way to check using 2 points A and B. If y2 is greater than y1 and x2 is greater than x1, then slope m is positive. But if y2 is less than y1, while x2 is still greater than x1, then slope m is negative. This connects nicely to the quadrant the angle theta lies in because the sign of tan theta depends on that. So the sign tells you whether the line's going up or down as you move across the graph. Picture 2 lines on the coordinate plane, one climbing upward, the other slanting downward, with plus and minus signs indicating their slopes. This visual cue is extremely helpful when sketching curves or analyzing functions. Now, let's get a bit more mathematical and see how slope relates to the angle theta using trigonometry. Imagine a line making an angle theta with the positive x-axis and crossing the y-axis at some point, say 0, c. To keep things simple, let's pick a point on the line that is exactly 1 unit away along the x-axis. That means the run is 1. because the line is tilted at angle theta. The vertical distance, or rise, equals tan theta times the run. Since the run is 1, the rise equals tan theta. So slope m is rise divided by run, which is tan theta over 1. And that simplifies to m equals tan theta. This neat derivation links the geometric idea of angles with the coordinate geometry method of finding slope. It builds a clear bridge between algebra and trigonometry. Now, visualize a right triangle resting on the x-axis. Its base, or adjacent side, has length 1. Its vertical side, or opposite side, has length tan theta. And at the base, the angle theta is clearly marked. That's the heart of the slope concept. To wrap up, let's quickly review the key formulas and ideas about slope. First, slope m equals tan theta. That's slope expressed in terms of the inclination angle. Second, slope m equals open bracket y2 minus y1 close bracket divided by open bracket x2 minus x1 close bracket, slope written as the ratio of coordinate differences. Third, the special cases. Horizontal lines always have slope equal to 0 and vertical lines always have slope undefined. Remember, slope measures how steep a line is using the tangent of its angle with the x-axis. The sign of the slope tells you whether the line rises or falls as you move from left to right. And finally, slope is undefined for vertical lines because dividing by 0 isn't possible, which fits perfectly with our geometric picture of a vertical line going straight up and down.